All right, we're going to do a couple of examples of some geometry questions. So our first question here, the instructions say, determine the measure of the marked angles in each of the following diagrams. So for this particular one, I have 3 different marked angles, X, Y, and Z, that I want to try to figure out the value of. And there's a table here. So we have the angle. We're going to write down what theorem we used. We're going to show some type of work if there was work involved, and then we'll write down what our final answer is. So just because they are listed X, Y, Z, you don't necessarily have to do them in that order. You can do them in whatever order you like. So when I look at this picture, I try to see if I can see something that's easy to find first and then go from there. So I do notice that I have 2 perfectly straight crossing lines. And when I have 2 perfectly straight crossing lines, angles on the opposite sides should be equal. That's what OAT tells us, the opposite angle theorem. So I know this angle here is 65 degrees. So I can actually find this angle here without doing very much work by just saying that Y is also 65 degrees. So for Y, what theorem was that? That was the opposite angle theorem. So I'm just going to write OAT. If you don't want to write OAT, you can write opposite angles. That would be fine. And then did I need a calculation for that? No, I did not. And what was the answer? 65 degrees. Okay, so then it gets a little trickier. I need to calculate X and Z. And there are multiple ways that you can do this. So one of the ways that I can do this is I can cover up part of the picture. And if I cover up part of the picture, I see that X and 65 together make a straight line. And I know that straight lines add to 180 degrees. Those are supplementary angles. You could alternatively look at it and see that there's a full circle going all the way around, which would add to 360 degrees. And these 2 angles should be equal, but that's a little more complicated. So I think I'm going to stick with that straight line. Now you will notice a lot of the time I will take a piece of paper or an eraser or my hand or something and cover up parts of the picture. If you're having trouble seeing what pattern you want to use, it does actually help to cover up parts of your picture so that you're not seeing everything at once. So I see that X and 65 make a straight line, and that is the supplementary angle theorem, or SAT. So here, for X, I'm going to use SAT. You could write supplementary angles. And then for my calculation, X, see, it helps to cover it up. X and 65 together are going to add to a straight line, or 180 degrees. So X plus 65 equals 180 degrees. And then I'm going to solve that by subtracting 65 and 180. Take away 65 should give me 115. So my answer is 115 degrees. Okay, it does help, by the way, if once you've found an angle, you label its measure on your diagram, because you might be able to use that to do the next part. So what I have left to find is angle Z. And I have a lot of different options for how to find angle Z. So option number 1, all together, all of these angles go all the way around in a circle. So I know they add to 360 degrees. That is the reflex angle theorem. Now, when it is the reflex angle theorem, you'll notice none of these are actually reflex angles. But if you were to add together the 3 angles that we know, they would make a reflex angle. So this is the reflex angle theorem. You could add the whole thing to 360. You could say, oh, look, there's a straight line. So 65 and Z should make a straight line, or add to 360 degrees. Or you could see a straight line there and say that these 2 angles add to 180 degrees. I don't know what I'm talking about. Straight line, 180 degrees. So this straight line, 180, or this straight line, 180. But I'm not going to use any of those. I am going to use my favorite theorem, which is OAT, which says that two angles on opposite sides of two perfectly straight lines are going to be equal. So Z should equal 115 degrees, and that's because of the opposite angle theorem, or OAT. I don't need to show any calculation. I can just say that it is 115 degrees. Now, you could use RAT, you could use SAT, it is entirely up to you. The only theorem you couldn't use here is the complementary angle theorem because none of these are right angles.